Okay, awesome. Good to see you all. A room full of amazing people. And this is my first time that I'm speaking here at Linux West, Northwest. And I was very excited to present something among many of you are experienced. And I have a bit of knowledge from this project that I have been working on, which I wanted to share. So this is one of the fun project that I started a couple of years ago just to solve my own problem. And as I saw that with AI, I can make it even better. So I jumped again and started again working on this side project that from the years back. So overall, today, let me first share the screen actually. I hope my screen is visible. If not, let me know. So we are going to talk about private LLM powered second brain, and we are deploying it on Linux on home computers, small devices, old computers, or tiny MCUs. So those are the devices that we are going to use, and we are going to create a second brain using that. So I'm Pradeep Sharma, and I work as a developer relations specialist. I basically independently consult companies to how to improve developer experience and engage with developers. So today's this is a brief overview of what I'm going to cover. Uh, we will talk about an anxiety of not doing enough, the work stress, and what's the solution to that, and my development journey to build this AI-powered second brain. And I'll share what worked and what didn't work. Uh, Eventually, by the end of the talk, there are a couple of things that I imagine that you may walk away. One is that if you want to build similar thing, then you will be able to not do all those things that I did and failed. So you will be one step ahead in building the same thing. And other than that, you will I will also share specific things. For example, deploying ASR, automatic speech recognition. So how you can do that on a tiny device, which is Raspberry Pi. So that is one thing. And second is the LLM. How do you deploy LLM locally on a very cheap machine? For example, i5 or i7 computer from many years ago, and that has only like 8 GB or 16 GB of memory. So, and then there will be learnings in each of those specific points. If you have been building LLM, building anything related to AI and wanted to build that locally, completely offline. So in those cases, you will have some of the insights that I gained from building this project. So just to give you an overview that why actually I'm doing this and how does it connect with my past experiences. So I studied electronics and computer department in the electronics and computer department at IIT Roorkee. It's based in India. By now I have more than 12 years of software engineering experience, and my work mostly involved full stack development, and I'm more experienced in backend related technologies. Right now, I'm consulting companies for developer relations, and I publish open source discovery newsletter where I review developer experience of various interesting open source projects that I come across. I have been doing this for past 6 years. I founded a community, a developer community called Invite, which is a community of remote developers who come from rural areas, tier two cities, or areas where uh, which are not in mainstream, like for example, San Francisco, for example, Bangalore in India. Rather, people coming from other states or other cities, which is most of the population. like 75% of the population in India at least, and more than 50% all over the world. So I built community of those people, and then built that, founded that in 2016. I have worked with, just to give you an overview, what kind of companies I have worked with. Gina is one of the company which builds multimodal deep learning pipeline, and I work with them. And specifically today, we are talking about this side project that I told you about. The name is Developer Diary, and this is a privacy-focused developer productivity tool. I built this tool for myself, and I use it on everyday basis. So before I share that, how many of you already use any second brain app? I assume most people would use, or is it a different case? Okay, I see. And how many of you have tried local LLM, running LLM locally? Okay, I see you. Cool. Okay, so let's get on to the talk now. So the problem that uh, why I was actually interested in building this was that there is a huge impact of work stress, especially in development. A lot of people have reported that they feel stressed about their job. And specifically when we talk about remote work, when people are working remotely, they have this pressure of not doing enough or wanting to do more, and they cannot let go when it is, let's say, 5 p.m. or just whatever time they decided that this is the time I need to let go work and be with my family or friends. They cannot let it go. And this anxiety is not, I have experienced it. Okay, I hope I'm audible.
Yep, we can hear you.
Okay. So, as I was saying that if you're feeling anxious today, the solution is simply journal. Just write things down. Whatever it's 5 p.m. You decided that you will leave work at 5 p.m. Then just simply journal whatever you wanted to do or whatever thoughts you have on your mind. You can come back and see those when you come tomorrow morning. And if you're feeling anxious about tomorrow, that what will happen tomorrow, have some worries, then how about you delegate that unfinished work to AI? Something that you're feeling that you won't be able to do, or you will be left behind if you don't do that. Then solution could be that you delegate that not so important work, but urgent work to AI. So this is the basically problem to the tiny problems, solution to the tiny problems. Now giving it a structure through second brain. So second brain has been a very popular term which was made popular primarily by Tiago Forte, and he gave this very organized structure of creating a second brain uh, with the purpose that it will help you reduce your cognitive load, it will improve your productivity, and it will help you be more creative. And the kind of organized structure he gave was capture whatever you have on your mind, organize those ideas or thoughts that you captured, and then distill them into some insights and then express them. So this was the sort of structure that Tiago gave, and that's what we can call a second brain. But if you have to just remember, I would say that whatever you have on your mind, and there is some digital system or whatever kind of system you have that remembers your ideas and then basically derives values from those thoughts and ideas. So in the app form, this developer diary, this side project that I was telling you about. So if I have to say what is it, then I will call it an offline AI second brain. It does not connect to internet. Uh, it works completely even when your network is down, and that is even when your network is up, it works offline only. And one key feature that comes out of it is that it protects your privacy. You are in full control. So, and the when I initially launched it 5 years, 5 or 6, actually long back, 5, 6 years ago, the the goal was very simple: that get things out of your head and then put those on your notebook. So I created this app, which is a desktop app, which is available on uh, Linux, Mac OS, Windows, everywhere, distributed on Snap as well. And simply you download it, and it's a simple notepad that you work on. Then there are other features which I won't go into detail because they are not concerned as far as this talk is related. So I wanted to basically take this to the next level using AI. So that's what we had, the offline AI second brain, which was doing sort of note-taking tasks. Now, actually, with AI, we can the kind of structure that Tiago gave this when you capture those thoughts and everything, how do you turn them into insights and bring some meaningful action out of those? So one thing that I wanted to do was that earlier we were capturing those thoughts by writing it down, by typing it in the app. But with the AI, I can go one step further and I can simply speak. And that has become very useful to me because now I'm able to capture a lot more ideas. Earlier, I was just writing 7 or 8 lines every day, but now in this notebook, but now I'm recording 30 minutes or 1 hour of recording, and I transcribe those ideas and I use this device, this Raspberry Pi, the model 4B, that's what I use, and it runs on, it has 8 GB RAM. So basically, imagine that you have this mic, this Bluetooth mic, you speak, and that is captured on your Raspberry Pi. That is again local. It's not connected to internet. So you have so your thoughts are captured on Raspberry Pi. So that's one way of actually capturing your thoughts and ideas by speaking. Second way, which is the old way, and it is still going to be there, and a very useful one, still very useful, is write. Simply type. So this is one of my entry from Jan 8 and a couple of years ago. So I just used to write that whatever I did, and sometimes whatever thoughts that I had, or people I met, and anything else. And other people, their mileage may vary. They can capture in a different way. But it was very unstructured, simple markdown file. So you are free to structure it the way you want. Now you recorded your whatever you had in during the day. You recorded those ideas. You wrote it down in this app. It's 5 p.m. and you leave the work, and nothing has happened actually. AI, you haven't even realized that AI has been used because it hasn't been. The time it starts now after you go off from your work. It starts organizing your those. First, it transcribes the speech that you had, this voice input. It reflects you. It uses LLM. So we used ASR for this transcription, AI model, and then we used an LLM to reflect on those ideas and even basically improve those uh, that text as well, make it more meaningful as well. So, and then reflect on that, and then eventually act on it. So we will remove this. organize and act for now, and we will simply focus on reflect yeah, for this talk. And for this, let's move on. That what's the impact? First, let's see what's the impact of this system. The next day you come when, let's say 7 a.m. or 9 a.m., then you will see that those ideas that you wanted to remember, those are there. Any insights that you found yesterday from your work or from your personal life, that is there. Or anything, if it were act as well, then if it acted, then it will also let you know that this is what it did. It could be a very simple thing like send posting on a community forum or sending an email. And most importantly, that I have found repeatedly useful for me is to just list down very simple thing, just list down all the unfinished work from yesterday so that I can continue where I left yesterday. So there are three key aspects of this system that makes it useful and privacy focused. One is that it acts as a second brain, and with that, one of the key uh, benefit that I have noticed that it has helped me in creative breakthroughs. I'm stuck in a programming problem. I'm not able to figure out that what algorithm should I apply here. There, I have applied a couple of algorithms, but I'm not happy with that. I want to make it even better. And that problem goes on for months that I'm thinking about that. And those are the kind of problem that this second brain system helped me to find the creative breakthrough. And second aspect of this system is the AI. AI is I'm offloading a lot of work now to AI, which I was not able to do earlier. And this helps me being more productive and even have more clarity about my work. And the third thing is it's offline, it's privacy focused and accessible. So why AI for second brain? I think we can skip this slide, but one thing only I wanted to highlight was that it helps in creative breakthrough by connecting those ideas, those unstructured ideas that you had captured, sometimes even from years ago. So that's the key thing that where this AI helps to do that. Earlier, without it, how I was doing this, I was doing weekly reviews. So anything that happened, I had captured this week, I will summarize those in the weekly review, and then eventually I will have to come every either the month or maybe end of year, and then again summarize all those weeks as well. And that took a lot of work. And in this process, a lot of information, a lot of ideas were lost. But with AI, this won't be the case. Why offline? Privacy and security is a very apparent, very clearly visible reason that yes, it's more private. It's not connected with the internet. You can have peace of mind, but and cost is also another aspect which is very clear that you don't need to pay any online subscription. It's free. You download it or you create your own, and it's working offline. You're not paying for tokens. You're not paying for monthly subscription. Nothing. So cost. The last part is accessibility. This is one thing that I really want to highlight that by making it offline, you make it accessible to people who couldn't have access to such tools earlier. Think about people who come from areas where the internet penetration is still low, and there are many such areas. People do not have access to good internet, and they can access this application. They can access the benefit of this application, but not just this application. This is why I am very obsessed about creating offline of any product. That how can we create offline version of that? Because it makes it accessible to people who come from remote areas, and privacy and the cost. So these are the reasons and how this apps work. Now, how I actually built it, and I will go through all the decisions that were involved. So first thing is that three things are involved, three hardwares. One is the Bluetooth mic, another one is this Raspberry Pi 4, and the last one is this old computer that I have, which runs on i5 and has about 12 GB of memory. And I asked some people in the community that I run that what system do they have, and their primary system is actually runs more for 80% of them runs on i5 or i7 and between 8 GB to 16 GB. So that's the kind of case we are talking about when we look at the larger picture when we look at the larger number of developers. This is what many people are using. Although there are very advanced systems and CPUs and even GPUs that people use, but not many people. Actually, many people are still using these old CPUs. So, and even if you are using these newer versions of CPUs or even have GPU, then still you might have one or two computers lying around and you can put them to good use by building this system. And the same thing I did. So now, how does it work? The networking. So this mic connects via Bluetooth to this Raspberry Pi, and anything that you say, anything that you record, it goes on and gets stored on Raspberry Pi, and from there, it is connected through to local network on your to your this old computer that you have. Via HTTP API, it can access those recordings or the transcriptions and perform the next actions that you will see. What are they? So, one goal of for the first goal of this project was that I should be able to record anywhere, and I can walk around and just keep recording. I should not be limited to physical space to record anything. That's where the true power of this thought capturing will be enabled. And it has to be completely offline. So that was a challenge because if you wanted to go anywhere, let's say you go outside your house, how would you do that? We were connected on this local network. So how do you do this? By making this device portable, which is why choosing this Raspberry Pi 4. It's portable. You can plug it to this power bank, or you can create your own power bank by adding this 3.7 volt lithium battery and adding some voltage booster, and it will work as a portable device. I have explored other devices as well, which are smaller than this, but but they were not doing the job. I was not. They wouldn't work. For example, a Pico that I used, there were limitations because of which I zeroed in only on Raspberry Pi 4, and we will see how that played out. So on the software side, so I use Linux and Whisper as for ASR or for speech to text conversion, basically transcribing the voice, and Python language. So seeing it in action. So you record the voice, it gets stored on this device. You went outside, then you can simply come back. The recording is still there on your Raspberry Pi. And if you have, let's say, even you don't want to use Bluetooth mic, you want to use USB mic, or maybe you have some digital recorder that where you are already accustomed to, you can simply plug it in. And that's one interesting thing about Raspberry Pi, that it gives you so many ports. It gives you two USB 3.0 port, two USB 2.0 port ports, and many other ports as well. So you can plug in your that digital recorder that you have, and your recording is again captured there. So gives you a lot of freedom and flexibility to uh, capture your thoughts. Then on the OS side, I chose Raspberry Pi OS. Actually, I used both of them. Let me just show you. I use this. I have two pen drives. One is one has this Raspberry Pi OS, and another one has this Ubuntu 24 OS. And I use both of them. And this is sort of a makeshift version of this Raspberry Pi 4, and with a fan and the sink to control the heat. But primarily I'm zero. I will choose Raspberry Pi for the purpose of this talk. And so this is what we use. Both are based on Linux. And Whisper, I chose Whisper as the model to transcribe a speech to text, and used Python to perform other actions such as chunking and then APIs and everything else that is needed to complete this system. Now, I can go into details of what models that I have chose, but just to actually keep this talk brief, I would rather just share that what models that I have tried. I tried this Whisper small, and I will share this complete sheet of research with you and after this talk. So Whisper small one, this is the one that I found that was working very well. It gave me it's slow. It takes about 30 minutes for a 30 minutes recording, and even more than that. It takes more than that, but its performance was good, and I didn't have any constraint of being real time. So that was one benefit for my use case, because it was working only after I log off from my work, and I need that transcription or the actions based on the transcriptions the next day. So it gives me 8 to 12 hours. So even I was okay with, if it would have taken, let's say, 3, 4 hours, I would be okay with that as well. So it takes about 2 GB of RAM and almost 200% of CPU on i5 I'm showing for now. I also tried a WASC small model. If I had this, let's say, real-time kind of requirement, then I okay.
Sorry about
So so basically, the thoughts you captured in voice or text, LLM, this brain turns them into insights. So that's the job of the brain. Now, this LLM is also working offline. But as I showed you that I have this old computer, and many of people in my community actually have this as a main computer itself. So this was the constraint that I had, that how do I run LLM offline on these cheap computers that that we will need to use every day. And these are the configurations that I mentioned earlier: 8 to 16G and Intel i5 to or i7. Storage doesn't matter. Okay, so the first thing that I tried. So the first thing I tried, that why even use the other computer? Why not simply run LLM on Raspberry Pi 4? And the uh, best performance that I found was from Llama file. So Llama file packs all the LLMs, activation weights, everything in one simple file. So it's easy to use and portable. So, and it also gives you good optimizations that you need for this device. So I used that. It didn't work. I was barely I didn't even get 1 tokens per second, quite slow. And the performance the quality was also pretty bad. So that's why and that was the best case which I got on a Raspberry Pi 4. So that was out of the question. So we had to go to the computer which has bigger resources, a better CPU, at least i5 or i7, better than this ARM Cortex. So now that I have a better CPU, but it's still not good enough for using any good LLM, which will give me a decent performance. My noteworthy is that my performance expectations are not huge. I have a very limited use case. For example, summarizing, extracting some of the things, and I'm not doing a huge work of reasoning, but still, the CPU that we don't have any GPU. Those are limited. So still, we need to overcome that challenge, that how do we run these big models on this old computer. So there are two things. One is that one can do. One is this model compression, and another one is inference engine optimization. So by doing two of these things, you can actually get run a decent LLM on your old computer. Many of you would have insights about this already. If not, let me know. I'll just quickly go through this. So one thing is that, so let's go about model compression. So, and also all these things, usually when you use inference engines, for example, Olama or VLLM or let's say Llama CPP, so you get all these things, and also there are already compressed models available out there. So all these things are already available for you. Most of the time, it's just a choice that you need to make rather than going into doing all these things yourself or fine tuning things yourself. So, but to just keep things in mind, then what questions to ask and what things to see when you are using any inference engine or you choosing a model is first thing that will bring impact is quantization. So quantization is basically you reduce the precision of your model's weight. Usually they are trained on FP32, which is 4 bytes, and you turn those into, let's say, int8 or int4. So you quantize those precision of those parameters of your model. Now, second is pruning, where you just simply remove unnecessary weights and neurons layers. And the distillation, this is one of the famous technique which this what do you call DeepSeek used, and which means that you train a model by following a bigger model. So you ask, sort of asking it to replicate the behavior of the bigger model. And there has been a huge work on this already, and there are already distilled version of big models available out there. And we have seen that how we get a, uh, an amazing performance but with limited resources. So that is on the model side, model compression side. And then second is that how do you effectively utilize the hardware that you have, this old computer. So and that is happening via this inference engine. And if you optimize that, then we again save some resources. Some of the points like parallel processing across use your all the cores of your CPUs, and use any specific optimization of your CPU, and use ISA specific features to accelerate those computation, and so many things. All of these things, and even the last one is prefix caching. So I will skip other things. Although you also get a prefix caching out of the box for most of these inference engine, as I mentioned, Olama, Llama CPP, and VLLM. But prefix caching is one thing that I will ask that you put more of your time on this, because this brings a huge improvement. And sometimes in some of the inference engines, you might need to specify this or be aware that you are using prefix caching. What is prefix caching? When this so one thing before this one thing that we need to know is that how LLM work is that the tokens the next tokens computation depends on the previous tokens. So that insight basically helps us to optimize. How? Think about the case where you are using the similar same prompt and then doing some of this stuff. For example, you're chatting with an LLM. So you have that request, you give the system prompt, you give some instructions, and then other stuff follows. Most of the time, in many use cases I have found, even in my use case, is that we are following similar pattern at until one point. And because the next tokens generation depends on this point, how about we save those or cache those activations and the whatever computations that this neural network has done, then we save a lot of time. And that was one of the insights that these many people, researchers figured out, and they started implementing this and gave it a cool name, prefix caching. So be aware that you are using, make sure that you are using prefix caching. And if you're using your own inference engine or using any not so popular inference engine which doesn't have a prefix caching, I would ask you to consider how do you develop that capability in that inference engine. So that's about the optimization. Now a sort of higher level, I'm expanding from there, that you need to run this LLM on your old local computer. The biggest mindset change is that be practical. When I started, I was trying to get more and more performance. I wanted to have the best model available for the task, which is usually not the right strategy. I was going for 13 billion parameter models, and I was because I expected more performance. But do I really need that performance? I was actually starving my computer of those resources, and that was actually creating more problems than the solution it offered. So don't stretch it. That is one thing I would say. Uh, I have for myself considered that if we am using 8 GB to 16 GB of RAM only and only on CPU, then I will simply choose any model that is between 3 billion to 7 billion. I won't go above beyond 7 billion. 8 billion, yes, okay, but the rough range that 3 billion to 7 billion, that's the parameter range that I will choose. And I wouldn't go for FP32, and I will use quantization, int8 quantization. And if I really want to try bigger model and int8 is not giving me the performance that I want, the TPS, then I will go lower than that and I'll go for int4 quantization. So this is being practical about your choice of model. And also, second thing is that being practical in your requirements as well. For example, I needed to get insights. I had this feeling that I need to get those insights immediately. But when I sat around and really thought about it, then I thought, no, I don't need that. I need this when I come back to my desk next day. So that's when it's going to be useful. That's when I'm going to act on it. So I don't need real time inference. I need only I have this 8 to 10 hours of window where this work can be done. So that is being practical and truncate unnecessary data. Very seems obvious, but I was doing that. I was not taking care of this because I was focused on higher goals. That how do I optimize my inference engine? How do I optimize my model and everything while ignoring the obvious things like truncating the unnecessary data. Do not add more tokens to your LLM calls if you don't need it. Summarize things that you can make your prompt concise And yeah, that's about truncating the unnecessary data. Then usually this will be done by this inference engine again. But if not, for example, Llama CPP, I think you will need to define these parameters, and then it will load your model to RAM. So this gives you faster performance. You do not need to read from the disk, rather you are reading from the RAM. It's faster. And simple hacker stuff any Linux user would do is to, for example, or a gamer would do is to use the your machine to the maximum extent that possible. So process prioritization is one of those things. You use a nice command. I use that, and I saw 23% improvement. And I might this tokens per second increased from 4.41 to 5.43. 1 token per second increase. That's huge. So that is thing, and miscellaneous other things that I wanted to try. One is this low latency kernel. So I didn't get opportunity to try that yet. I have done some basic research and still wants to learn more. If any of you have any ideas, would love to hear on that. And simple things like overclocks clock CPU, you can do that to again increase performance of your LLM on this local machine, and improving running a RAM at higher speed. If you have 2400, let's say, your RAM speed, then increase it to 3400. Usually, you can do those by changing from the BIOS settings. I was not able to do that, and I'm not sure why it happened, but I'll go ahead. That's something that I will try in future again. So yep, that's about this talk. Thank you, everyone. I do check out my newsletter, Open Source Discovery. It's free, available on Substack. Been running for past 6 years, and you can connect with me on LinkedIn and check out my work on GitHub as well. Email me if you need any of these sheets. For example, this research about the models that I have tried and what I found about them related to speech to text transcription, and or running your local LLM. So what things to try, and if you want to fine tune under like $500. So these are a couple of the things that I have uh, created a document on, and I would love to, if you want, I can share with you as well. That's about it.